Hey guys, this is Abhishek and welcome to the second video of linear regression. And if you remember, in our previous video we have seen the relationship between the average number of rooms and price in $1,000, as well as we saw the distribution of the target variable, which is the price in $100,000. Okay, so what I'll do is I will move ahead with the first step, which is the creation of linear regression model with the one variable. And then in the second step, we will look at the linear regression model building with the multiple variables. So let's go ahead and use the average number of rooms as our first predictor variable to predict the price in $1,000, as it shows a linear upward relationship. So what we will do is we will try to find a line of fit which will minimize the differences and best represent all the data points, and that's the objective of the linear regression, to find the best fit line which can represent all of these data points by minimizing the differences from the line. That's basically the overall theory is. But if you are really more interested into theory, because it has a lot of other parameters, like as I mentioned, the differences, it is called variation. So there is something called RSS, which is regression sum of squares. There is ESS, there is TSS. So there are different components. I'm not going too much in theory, because when you actually use it, you will get used to of it. But if you are really interested, I will really suggest two things. First is Wikipedia, and second is the YouTube channel of Brandon Folds. He has really explained it well. Even I have benefited a lot whenever I had any confusion or anything. Apart from that, well, books are always our best companion. So I have used one of my very favorite book, which I have purchased long back, and whenever I had any issues. And the book name is Statistics for Managers. And you can find it online on Amazon to really buy it. So let's go ahead, and first of all we will see the line of fit with the help of Seaborn library, and we will use the LM plot, the linear model plot, to find the regression line. So let's come here and write sns.lmplot. SNS is the Seaborn library. If you remember from our first video, we have imported it here. Import Seaborn as SNS, and it has a very customized visualization for our advanced use cases. And lmplot is one of the very straightforward, because you just need to specify x-axis, y-axis, and the dataset name. Alright, so the x-axis is our this average number of rooms, and y-axis is basically the price in $1,000. So what I'll do is I will simply copy this, right, and put it over here, and let me execute it. Oops, looks like we missed giving one of the data point, which is data, and let's give it Boston. And if it shows error, then probably we may need to convert it into a data frame, because right now what we have loaded is the toy data set. So let's go ahead and try to see it. Yeah, as I expected. So what I'll do is very quickly, the issue is that what it is expecting is a data frame. So what I'll do is I will say Boston underscore df and pd, which is a pandas library. I am getting the data frame, and my data frame is basically Boston.data, because it has all the variables, right? So if I comment it out, so that's number one thing, that we are getting the Boston underscore df, and then we also need to get Boston underscore df dot columns, and this is nothing but the feature names. So let's go ahead and execute this and see if we are getting any issue. Nope. It's pretty straightforward. We have got the data set, which is this. We have got this columns as feature names. Now let's do the last thing, which is Boston underscore df and let's get the price as the last column, and that is nothing but Boston target. And let's see this. Now we have the price as well. That is a price in $1,000. Okay, so now we are good. What I'll do is I will just cut this so that I don't have to write it again. Paste it here. Remove this, and let's remove this piece and this piece over here. So our x-axis is RM, so I'll give RM. Our y-axis is price, and our data set is Boston_df. Let's execute it now. Okay, now it's coming perfectly, and as you can see, this line, this is the standard fit line, indicating that from here there all these different variables which is away from the line, whether upward or downward, best represent this by minimizing the difference from the line. So that's why it is called the best fit or standard fit line, that well represent all of your data set values which are plotted on the chart. And this gray area, if it is properly visible on your screen, is basically indicates the confidence interval. As you know, it is moving towards center, you can see that it is minimizing, and if it is far, then it is increased, because as you can see, the data set, these data values have also pretty far, and here they have pretty much grouped it very closely to the line, and that's why this confidence interval is also reduced. Alright, now let's move ahead and do the linear regression modeling with the help of one variable. And as you know that the equation of the line is y is equals to mx plus c. It can be anything. Sometimes they call it bx plus c or mx plus b, but the idea is that y is your dependent variable, x is your independent variable, m is the slope of the line, right, or a rate of change based on 1 unit change in x, the resultant change in y, and then c is basically your constant error that is there in the line. So what we need is, first of all, specifying y, identifying y and x, and then model it out to figure out m plus c to build the equation of the line. Okay, so our x-axis, the value for x is the axis value on x-axis, which is room. So that is basically your Boston.data, and we need all the rows, and we need, in this one variable case, we need np.newAxis and 5. So what is really happening over here is that in the Boston.data we are getting all the rows, since whatever is before the comma is indicating row, and then after the comma is column, and after the comma what we are specifying is the np.newAxis, because it is a requirement of your linear regression that at least one axis should be present. So we are just giving one dummy axis to this, and saying that we also need the 5th column. And once you are done with that, and that's basically a case only with the one variable. When you have multiple variable, in that case you don't need it, because you get multiple because of the multiple variables you get multiple axes. Okay, so y is your nothing but Boston.target. So we are here. Now let's say linear regression. To initialize the linear regression, I think we should have imported over here. If not, then what we need is simply from sklearn.linear model import linear regression, and then linear regression. After you have initialized the linear regression, what you basically say is linreg.fit method, and you need to pass the parameter x and y. And that's pretty much all that you need to build your linear regression model. Again, just to revise it, what we are doing is from the sklearn, which is a scikit-learn library, we are importing linear model library or a sub-library, and in that we are importing the linear regression function, and we are initializing this function to pass on the methods or the pass on the methods like fit and other methods like predict. In future we will use that to fit based on the x and y axis. Okay, let's go ahead and execute it. So now we have the linreg, and if I want, now I can get my other values, the slope value and the coefficient, the c value, which I showed you. So how I can get it is basically linreg dot intercept, and here I have the intercept value, and linreg dot coefficient colinreg coef, and that's my coefficient value. So this intercept basically represent the c part in that equation. So if you remember, y is equals to mx plus c. So we know what is x is and we know what is y is, and we are trying to identify m, which is a slope, and here is the value for slope, and c is basically your intercept, and this is a negative value over here. So with this way you can create your line to identify. You can just provide the value of x, that means the number of rooms, and that number of rooms will be multiplied by this minus this one, because this is a negative value. So let's say if I'm saying I want to identify y in case of a 5 room house, so in that case what I will write is 9.1. To predict that, I need to write 9.1 multiply with 5 rooms minus 34.67, and whatever will be the outcome will be the price of that house in the thousands of dollars. Okay, so it should be somewhere around $10,000. So based on that, so if I see that 9 multiplied by 5 is basically 45 minus 34 is somewhere around 11, and if we see for 5 room, the values are roaming around somewhere around $10,000 or somewhere around that, and in the price in $1,000 axis. So this way you can basically say that how you can write the equation with the help of intercept and coefficient, and then you can keep on changing the value of this. The only caveat I will give you based on my study and my understanding of linear regression, that in this case the rooms are starting from maybe let's say 2 or 3 and let's say going up till 9, and if you're trying to predict 12 room house or a 13 room house, that will not be right, because that has not been scoped into the equation. So you should always pass on the x value, the independent variable value, if it is part of your model, like 6, 7, 5, 8, to get the estimated price of the house by looking at just one factor, which is the number of rooms. And then there can be other factors like crime and locality ratings and things like that to really impact that. But right now we are just looking at the one simple factor, which is the number of rooms, and the number of rooms should be anywhere between in this case maybe 2 room to 9 room, right? So that's just a caveat. I wanted you to understand that if you are trying to predict it, if you are going out of the bounds of your x-axis, that will not be right. Okay, the last thing I will do is the use of predict method, and I will just pass the value, the testing value, now in this case 5 as a testing value. I don't know what happened here, 5, and that's what you are getting, the value 10. Similarly, if I want to predict now the 8 rooms value, this is 38. So you can just simply go ahead and pass on this model, and this way you can get the average or the estimated average price of your house that you are looking for. So this way you can basically gain a understanding looking at different variables, either single or multiple, about what should be the estimated price. And if you have a website or something like that, you can pass that equation to your website, which will then calculate it for your users, and you can gain the confidence of those users. So in this video I have shown you how you can use it for how you can create the linear model with the help of single variable, and in the next video I will show you how you can produce the model with the help of multiple variables. So stay tuned for that.